Hello everyone. So today we will be talking about coordinate geometry 1. This is the fourth lecture of the series from high school to physics. In this series we actually try to bridge the gap between the mathematical skills of a high school student and what is required to be a physics bachelor student. Okay, so in this lecture I will be talking about a little bit of coordinate geometry. I'll be giving an introduction and then we will see what we can do in this lecture. So first of all, what is coordinate geometry? To understand that, we need to understand these two words: what is a coordinate and what is a geometry. Well, geometry is nothing but a subject that deals with shapes. It deals with shapes. Okay, we have learned geometry in our primary schools about triangles, squares, rectangles, all of those shapes. And now coordinate means to a numbered way to identify different shapes. You can say that we will see soon what a coordinate is. Firstly, I would like to tell about the number line. The number line that we learned about in our, I think, very first mathematics class in our primary school. So, what is a number line? A number line is nothing but an infinitely long line on which we define a scale. It's just like a ruler which never ends. So, we first define the scale, like how far the ticks, or the ticks means this is a tick and this is a tick, how far they are going to be, and what and what will be the distance between them. Yes, so that is the scaling of that line. And after that, what we do is we set a reference point. What is a reference point? A reference point is nothing but we just pick a tick, we just pick this where we say that this is 0 and this is 0, and then we say that on the right side we are choosing all the positive numbers. So this is 1, this is 2, this is 3, this is 4, and on the left side we choose all the negative numbers. Okay, so it goes to positive infinity and the left side goes to negative infinity. And it's just a convention. You can choose positive sides on the left side also, but I am just writing according to the convention most books follow, so that you don't have any problem matching them. Okay, so this is just a number line which has numbers scaled on it. And so if I want to say that, look, suppose I want to say that I want to mention this point. Okay, let me just choose a different color. I want to choose this point. Then what will I do? I will be just saying that this is point 3 at point, this is the point at 3. And I want to choose this point. I will say that this is the point -2. So this number here 3 and this number here -2 is nothing but the coordinates of the points on this number line. Okay, so these are called the coordinates, and so we can guess where the point is by looking at the coordinate of the point on a number line. We will soon see that even on a plane or on a 3D space we can define coordinates to locate points at, we will see soon. And firstly, what we are going to do is, suppose on the number line we have a point called x1 and another point called x2, and we want to say that we want the distance between them. So what will be the distance between them? It's nothing but x2 minus x1. Okay, if 0 is here, then x2 is the distance, this one, and x1 is the distance of from 0 to x1, and so this is x1, this is x2, so this is definitely going to be x2 minus x1. Even if 0 is at the middle of x2 and x1, then this one is minus x1 actually, so that this distance is minus x1 and this distance is x2. So what will be the total distance? It will nothing but x2 minus x1. Okay, so that gives us x2 plus x1. Okay, so you can see it clearly that it just the distance gets added. So this is how we can figure out distances. We can figure out distances in our one-dimensional line or number line. Okay, so let's I just mentioned that number line is one dimensional. So what do I mean by that? Okay, so we will going to learn a bit about Euclidean. I hope I am writing the spelling correct, about Euclidean dimensions. It's a very cool thing. Okay, so at first we suppose I have a point here. If the point has no length, no width, no height, so we say that this has zero dimension. This is a zero-dimensional object. So in short, I will be writing d equals 0. And then in the next step, we draw another point and join them. Okay, and now what we have got is a line. It is nothing but a line. And now it has dimension of 1. It has one dimension, it has one axis, commonly noted as x-axis. You can give it another name, you can give it any name, you can say this is a-axis, b-axis, whatever. I am just writing according to the convention most people use. And then if you have two lines, that means two one-dimensional object, two different, and then you join similar points here, then we get a two-dimensional object called a plane. Okay, and just like a line which had one axis, plane has two axes because its dimension is 2, most commonly noted as the x-axis and the y-axis. Okay, so this is a plane. And now if we draw two planes, and join the equivalent points, then what we get? We get a three-dimensional object, a three-dimensional space, and this space all has three axes: x, y, and z. X, y, and z. Okay, so this is the method that Euclid mentioned to understand dimensions. Okay, so as we are doing coordinate geometry according to Euclidean axioms, that is Euclidean geometry, and you don't need to know what Euclidean geometry is yet. You will get to know it in your late physics program. Okay, so you don't need to know it now. Just remember it's Euclidean system. And using the same system, can we draw a four-dimensional object? The answer is yes, we can draw. Suppose we have to draw a four-dimensional object, we have to first draw two three-dimensional object. First of all, let me just tell you something. This is a plane drawn on this plane is drawn on a plane. Okay, because the surface that I'm drawing on is a plane, is 2D. But this is a three-dimensional object, a cube but it's not exactly a cube because I have drawn it on a 2D surface. So this is nothing but holography of a 3D cube on two-dimensional plane, because I have drawn it on a 2D plane. I cannot draw a 3D object on a 2D plane, right? Okay, so now I'm just going to draw the holography of a four-dimensional object on 2 dimension. Okay, so let's first draw two three-dimensional object, then we will just join the equivalent points. Okay, I just made a mistake, let me fix that. Okay, yes, so this thing is a four-dimensional, this has four Euclidean dimensions, and this thing is normally called the tesseract. It's a tesseract, just nothing but a four-dimensional cube, and it has four axes: x, y, z, and a fourth one, x, y, z, and the fourth one is called w, naturally denoted by w. And what are the dimensions here? There is length, there is width, there is height, and the fourth one is normally called strength, but I don't know if this is the convention that is still getting used. I don't know that. Okay, so this is the four Euclidean dimensional object, a tesseract. Okay, so we will not be dealing with these type of objects, don't worry. So now we have seen that in one dimension we are getting a line, and we can number that line using a different scaled ticks, and just pointing a reference point called the origin or 0. And so similarly we will do this for a two-dimensional plane. For a two-dimensional plane we have two axes. We have x-axis and we have y-axis, and normally the intersection of x and y-axis is chosen to be our origin. That means on x-axis there is a number line which has its 0 here, and on y-axis there is another number line which has its 0 here also. So this has two zeros, a 0 for x-axis and also 0 for y-axis. So this is how a coordinate is written in multiple dimension. And similarly the positive and negative convention is like this. The right side is positive x, left side is negative x, the upside is positive y, and the downside is negative y. And so any point here, it can be denoted as this. It can be denoted a comma b, with the first number being the coordinate of x-axis, coordinate of x-axis, and the second is the coordinate of y-axis. Well, the actual terminology is not coordinate, is ordinate and abscissa. I'm not going to use them. You can look it up in any book. I will be saying that these are the coordinates. Okay. Normally, I think this is called abscissa and this is called ordinate, but I cannot recall what exactly are called. Okay. So what does that mean? That means that this point, if I draw perpendicular from this point on x-axis, then the point where the perpendicular intersects x is nothing but a on the number line of x-axis, and it's as y has 0 along the number line of x, we have 0 in the coordinate of y. And similarly, if we intersect y-axis with a perpendicular drawn on it from that point, this point will be 0 for x because it's on the 0 of x, and b for y. So this is how a two-dimensional coordinate system is written. And what will be the distance of a two-dimensional coordinate system? Let me draw another one. Suppose this is a point and the coordinate is x1 comma y1. That means that its distance from x-axis is y1, this distance, and its distance from y-axis is x1. And there is another point called x2 comma y2. That means that this distance is y2 and this distance is x2. We want to find the distance between these 2 points A and B. And what will be it? Okay, so we all can recall, I think we all know what a Pythagorean theorem is. Pythagorean theorem, that for a right angle triangle with base, height and hypotenuse, we have this formula. We will be using this formula to find out the distance between these 2 points here. So how can we do that? We have to build a right angle triangle, obviously. So let's draw a right angle triangle by drawing this line. So this is a right angle triangle, AB, and suppose this point is C. ABC is a right angle triangle. So all we have to do to find this distance is to find this one and find this one, then use Pythagorean theorem. So we know that this whole distance is y2, this small distance is y1, so this distance is definitely y2 minus y1. Similarly, this whole distance is x2, this small one is x1, so this must be x2 minus x1. Okay, and how to find, then we are going to use this formula. So let the distance be d, then d square will be equal to x2 minus x1 whole square plus y2 minus y1 whole square. Okay, so let me just root this equation and we get a formula like this. Similarly, if we have a three-dimensional coordinate system x, y and z, then we will get a distance like with the same formula x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. Okay, it's d3, it's d2. In the case of number line, we also had the same formula, but as it has only one dimension, it's just this, and the root cancel out the square, and this is just x2 minus x1, what we got previously. Where is it? This one, what we got. Oh no, sorry, not this one, this one, not this one, x2 minus x1. Okay, so yeah, so using summation sign, we can say that an n-dimensional coordinate system, we can define distance between 2 points. Let the first point A has the let it have the coordinate of xi. Okay, what is xi? That means that, okay, let me write it like this. It has coordinate x1 comma x2 comma dot 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 xn. It has n coordinates, and another point is B. It has y1 comma y2 comma dot 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 yn. Okay, so what's the distance between these 2 points? Is nothing but summation of xi minus yi whole square from I equal to 1 to n, and then rooting over the whole summation. Yes, this is the distance formula. You can check this, that this distance formula comes from Pythagoras theorem only. Remember that this distance formula works for Euclidean systems. Okay, for non-Euclidean systems, distance formula gets a little bit changed. You will see that in your later courses. And one property of this distance, that distance is always greater than or equal to 0. Distance can never be negative for Euclidean geometry. Okay, so now after we have figured out distance formula, we will see how to plot things. We will see some 2D plots. Let this be my y-axis, this be my x-axis, and I want to plot a function y equal to a function. Okay, a function of x. Let that function be, suppose we have y equal to x. We want to plot this y equals x. Nothing fancy here. So I'm going to follow the most conventional way here. I'm going to do a checkerboard system. I'm going to write x here, y here, and I'm going to write some points. First of all, let me draw for x equal to 0. What is y? If we put here x equal to 0, we will get y is also 0. Okay, so 0 comma 0 is a point. That is the origin. Let me choose another color. That is the origin. Now next, let's choose 1, x equal to 1. Then y is also 1. That means that 1 comma 1 is also another point. 1 comma 1. And if we choose x equal to minus 1, then y is also minus 1. That means that minus 1 comma minus 1 is also another point. That's on the graph is here. And now if we join these lines, then we get the graph of the system. The graph of the equation, sorry, not the system. I'm sorry. Let me check that we're using Desmos. Using Desmos, let me just, you can use any other graph calculator. I'm going to write just y equal to x. So yeah, we got the graph right. Let's draw another graph. Suppose we have y equals x square plus 2. Okay, let's draw it. Okay, so let's draw the checkerboard once again. For x equal to 0, what is y? You can see that by putting 0 here in the equation, in the function of x, This is the function of x here. So by putting 0 here, we get that y is 2. So 0 comma 2 is a coordinate. Suppose that is here. And if I put 1 here, then we get y is 3. If I put minus 1 here, then y is also 3. If I put 2 here, then y is 2 to the power 2 is 4 plus 2 is 6. And if I put minus 2 here, that's also 6. So what are the points? 1 comma 3, 1 comma 3 it is here, minus 1 comma 3 is here, 2 comma 6 is here, minus comma 6 is here. So if we join those lines, we will get a curve like this. Okay, it's a parabola. We will know what a parabola is in our later lecture of coordinate geometry, but first let's check that our graph is right on our famous Desmos app. Okay, so we had y equals x squared plus 2. Where is that graph? Oh, here it is. Yes, we got it right. Look, the coordinates that we got, 0 comma 2 we got. We also got what point here? Oh, sorry, the point is not shown here. Okay, I'm sorry. Oh, here it is. You can see that it's 1 comma 3 almost. Okay, 1 comma 3. So all the points you can see here. Also, let's draw some other functions as well. Suppose there is a famous function called the mod function. What is the work of a mod function? It just let me give you an example. Modulus of 2 is nothing but 2. Modulus of minus 2 is also 2. It just, whatever you put inside modulus, it just gives the positive value output of it. Okay, how to write it in algebraic form? Suppose f of x is modulus x, that means that it is equal to x when x is greater than or equal to 0. That is, when x is positive, that means that mod x is x, just like here. Mod of 2 is 2, as 2 is a positive number. But when x is negative, it gives minus x when x is negative. Why is that? Because when x is negative, suppose here, when x is minus 2, it outputs minus of minus 2, that is positive of 2. That's why our extra minus sign comes here, because x itself is a negative number. So putting a minus sign before a negative number makes it a positive number. So how to draw it? Let's draw the graph. Let's see our checkerboard once again. Firstly, 0 gives 0. Yeah, if x is 1, that is greater than 0, so output is x, so y is also 1. If x is minus 1, that is less than 0, so output is minus of minus 1, that is 1. Okay, so if we draw the graph here, we will see that it looks like this. Okay, let's check the graph. Okay, just a minute. Yeah, y equals mod of x. Yes, we got it right. This is a V graph, y equals mod x. Where is the left one? Yes. And there's another called a sigma function. I think it's sigma function. I have forgotten. If I am wrong about the name of this function, then please, sorry. I apologize prior to my mistake. I don't know if it's called a sigma function or not. I'm unable to recall it. Okay, forget about the name. Suppose this is a function mod x by x. So what is the output of this function? When x is greater than or equal to 0, firstly remember, when x is equal to 0, this function is undefined. Y is undefined, because you cannot divide something with 0. It's not infinite, it's undefined. Infinite is not undefined. These are two totally different concepts. When x is greater than 0, that means x is positive, then y is mod x by x. If x is positive, then mod x just gives x, and this is 1. And when x is negative, y is mod x by x, and if you put a negative number inside mod, then it gives minus of that number. So it's minus 1. And then the graph will look like this. Sorry, just a minute. Okay, graph will look like this. This is 1, 0 comma 1, this is 0 comma minus 1, this point. So graph will look like this. Okay, let's just check. Okay, just dividing mod x with where is the division? Here, mod x with x. So yeah, we got it right. There are other functions. Let me show you here. Just there are trigonometric functions you can draw. Y equals, suppose I have a sine of x. It looks like this, a sine wave it is called. Sorry, a sine wave. There is also other functions called y equals, we have e to the power x. This is an exponential function, the violet one. Also there is another function called a log function of a log. Where is the log? Let me just find the log. There's ln, or ln means base of log is e, log means base is 10, so I'm going to use ln. And yeah, this is the graph of logarithm. Okay, so this is, I think this is the basic idea of how to plot and how to understand different graphs. And so this will be all for today. I'll be ending my class here, and on the next lecture we will know further structures in coordinate geometry, like straight lines, circles, and other structures. We will see that. Okay, so for now, it's bye.